Hello, ladies and gentlemen. Welcome back to Chapter 8, another exciting movie by Mrs. Harmon. Today we're going to continue to discuss triangle proportionality theorems, use the converse of it, and some other proportionality theorems that allow us to find missing lengths in triangles and other geometric figures. So the first thing we want to do is we want to get down the triangle proportionality theorem written down. And I would also suggest, as you're writing it down, that you get the picture as well. It says, if a line parallel to one side of a triangle intersects the other two sides, then it divides the sides proportionally. So the picture that we have here, it's telling us if those two sides are parallel, QS and TU, then if I would compare side RT to TQ, that should be proportional to side RU compared to US. So we've seen something like this in some other pictures we did earlier in the chapter. I believe it was in section 8.2. But we're now comparing the sides of the triangle. The converse to that. So now we're going to flip the hypotenuse and the conclusion. And it says, if the line divides the two sides of a triangle proportionally, then it's going to be parallel to this third side. So this is telling us if RT compared to TQ, or over TQ, is equal to RU compared to US, then those two lines are parallel to each other. So now we're going to take these two theorems and put them into practice. If we take a look at number 1, it's giving us the information and it tells us that QS is parallel to UT. So that should be dividing the triangle proportionally. They told us that RS is 4, ST is 6, QU is 9, and they're asking us for RQ. So I'm going to call that X. Using the triangle proportionality theorem, I should be able to compare X to 9, and that should be equal to 4 over 6. We cross multiply, we divide both sides by 6, and we get X is 6. So RQ, what we were looking for, is actually 6 units long. That's using the triangle proportionality theorem. In this next example, they're asking us if something is parallel or not parallel to the floor. I don't know if you've ever seen any of these shoe racks. Here's the actual kind of shelf that you put your shoe on. And they're asking us if that shelf is parallel to the floor. I don't know if you can tell. It almost looks like it's kind of slanted or tilted. But we can prove this mathematically. It says BA is 33 and CB is 27. CD, so this piece here, is 44. And DE is 25. So if indeed the shelf is parallel to the floor, I should be able to write a proportion that would be true. So I'm going to compare 27 to 33, and that should be equal to 44 over 25. That's the question. Are they equal? Well, when I cross multiply, I get 675 is equal to 1452, which is not true. So the sides are not proportional, so the shelf is not parallel. So that's using the converse. Another important theorem in this chapter is the 3 parallel lines theorem. It says if 3 parallel lines, here they are, 1, 2, 3, intersect 2 transversals. Here's one of my transversals, and here's another one. They're dividing the transversals proportionally. So if we take a look at this picture over here, it's saying that UW, this piece, over WY is supposed to be equal to VX over XZ. And as you can imagine, that would allow us to solve lots of different things because it's not just necessarily a triangle here. So now we are going to apply the three parallel lines theorem, this picture, which kind of looks like a city map. And it's telling us in our diagram that angles 1, 2, and 3 are congruent, which would make Main Street, 2nd Street, South Main Street all parallel. And we can see that FH and EC are both those transversals then. Our job is to find the distance of HF. So we're actually looking for this entire distance here. But they give us some information that GF is 120, DE is 150, and DC is 300. So we can apply the three parallel lines theorem by saying, well, let me find this piece here, X. And we can write a proportion. 120 compared to X is proportional to 150 over 300. Again, all proportions within this chapter. 150X equals 36,000. Divide by 150. And we would get that X is 240. Now keep in mind that they didn't ask us just to find this piece. They asked us to find the entire distance. So if we're answering their question, the question would be actually 360 yards. So you always want to make sure that you're answering the question that they're asking us. The last theorem we're going to take a look at is the triangle angle bisector theorem, which says if a ray bisects an angle of a triangle, then it divides the opposite side into segments whose lengths are proportional to the lengths of the other two sides. Which, for a moment, that might sound like, wow, that's a lot. But what it's saying is when we have this bisector, it's taking this side and it's splitting it so that the two pieces that it's split into, AD compared to DB, which is this piece, is going to be equal to the side that AD is on, which is AC, compared to CB. That's one proportion, but we know lots of times there's many other ways we can write proportions. I actually like it better when I say to myself, okay, if I take side AC, which is this one, and I compare it to the piece it's connected to, AD, it's going to be proportional to the other side, CB, and the piece it is connected to, DB. So my proportion looks different, but honestly, when you cross multiply here or here, no matter which one you do, you're still going to get an AC times DB equals AD times CB. There's lots of ways you can set up that proportion. So now we're going to try an example, and we're going to put the triangle bisector, angle bisector theorem into play here. So it tells us in this picture that QPR and angle RPS are congruent to each other, and if we take a look at the angle bisector, one arc. So that allows us to use the triangle angle bisector theorem. Now we have to pay attention here because this entire side is 15, and this piece is X. This is what we're looking for. What they didn't tell us is what QR is. But we can label QR as 15 take away x, which hopefully makes sense. If the whole thing is 15, take out the x I'm looking for, what's left over. So using this theorem now, I can compare side PQ to QR. And what that would look like is 7 over 15 minus x. And that should be proportional to the other side of this triangle, which is PS, compared to RS, which is what I'm looking for. So that's equal to 13 over x. We're going to cross multiply, and we get 7x equals 195 minus 13x. We add 13 to both sides, and we get 20x equals 195. And when we divide by 20, x has the value of 9.75. So we just figured out this part here, RS, which we called x when we were solving, is 9.75. You can put units on there. What I would like you to do now that you've taken your notes is give number 5 a try. It's a similar question to what we just did, however, maybe a little easier because this piece is labeled X and this is labeled 14. And when you come into class tomorrow, we'll spend some time during the class period doing problems on 8.4, making sure we have a good understanding of these concepts.